In this session, we will discuss how to move from the define phase, where we identified the voice of the customer, and how then to move from our process flow of the key steps of our process to identify the critical to quality characteristics of our process. The learning objectives are to be able to translate the voice of the customer into critical to quality characteristics, or CTQs. And we want to be able to identify the unit, the measure, and specifications for these CTQs. So just to recap a little bit, we talked about defining quality. We talked about the different dimensions of quality, reinforcing the idea that quality has many aspects and cannot be easily defined. It may have different meanings for different products, and even for the same product, depending on the market and for the different customer. We talked about the different types of quality aspects, for example, performance, reliability, durability, even sustainability. And we said that for a complete definition of product quality, you need to identify the needs and expectations of the customer. The designer needs to take these into account and select features of the product to create a design. Quality must be defined for each product based on what the customer wants in the product design through measurable characteristics and their limits of variability. And these product features are called the critical to quality characteristics, or CTQs. We also talked about the two aspects of quality, design quality and conformance quality. And here we also mentioned that in design quality, when we're looking to see if the design satisfies the needs, how does it compare with competitors? Here we're looking at the voice of the customer, and we've identified then what is critical for the customer. Conformance quality, we're seeing if the process output matches the specifications. Are our CTQs conforming to what we've set as specifications in our design? So finally, CTQs, critical to quality characteristics. These are the key measurable characteristics of a product or process whose performance standards or specification limits must be met in order to satisfy the customer. These must be specific, measurable, and actionable, which means capable of being acted upon, capable of being used. We could talk about something physical like length or weight or strength. We could have talked about some kind of characteristic to do with the senses, like taste, sweet or sour, appearance, color, light or dark, smoothness, for example. These also could be time-oriented. We have ideas like reliability, durability, serviceability. Look at an example. Here we have a call center. So what, as a customer, do you expect when you get on the phone and you want to know when the bus is leaving, or you want to book a train ticket, or you want to order a product? Well, normally, voice of the customer is telling us we want an immediate response. We don't want to listen to the music online. Well, that would mean our CTQ, our critical to quality characteristic, is going to be responsiveness. What are we using? What unit? Well, we're going to be looking at each call. And what's our measure? Well, how about put the time on hold, time that we have to wait. And normally this would be measured in call centers in seconds. And what do we want as a specification? Well, here, this depends. And we have an example in a minute. Specifications. It can be the voice of the customer, immediate. Maybe that's not entirely possible. So we look at a specification that is reasonable, something that we can specify that we would then maybe improve on, or something that at least is equivalent to what the competition offers. So for example, less than or equal to 30 seconds on hold. And a defect then is if you're greater than 30 seconds. A defect occurs in your process if a customer has to wait more than 30 seconds. So let's have another example. The pizza company again. Voice of the customer, what do we want? Voice of the customer, we want a hot pizza. we want a choice of toppings. We want to pay a competitive price. So most people offer hot pizzas with choices of toppings, so it could be the price is your differentiating factor there. How does all the students know you want your pizza right now in the middle of the night when you're hungry, when you're in the middle of studying? So let's take our voice of the customer, let's take our right now, and let's look at the three different parts here of our process that we've written out. We've got the customer level here, what the customer wants, and then we have the product that the pizza shop is offering a product, pizza delivery. And then we have the process level. What is happening to make this product happen? On the customer level, we see three measurable, actionable, critical to quality parameters. We have CTQ1, 24 hours availability. Want to order your pizza anytime, middle of the night, weekends, vacations. We want to have a quick ordering process, no waiting time, and we want to have the delivery instantaneously, immediately. These are your critical to quality parameters for a pizza right now. Now we look at the product level. And here we can start to set targets. So target for our critical to quality parameter 1, 24 hours availability. Well, turns out that's not going to be possible for our pizza delivery, but we will try to do 10 a.m. to 2 a.m. And that means 10 in the morning all the way until after midnight, till 2 in the morning. So pretty much the high pizza ordering time. That's going to be our target. Then we also have a target for CTQ2, which would, let's say, our 30 seconds again. We want people to be less than 30 seconds on the phone. Otherwise, they might hang up and go to another competitor. And we have then on our product level, well, immediate delivery we can't do. We'll try for minimum delivery. So here we're going to have the targets less than 10 minutes to prepare the pizza and less than 20 minutes to deliver the pizza. So beyond this then, we can divide our targets into different sub-targets, which would then allow us to meet the particular targets that we'd have. We can look back into our process, the order entry, the preparation, pizza baking time, baking time, packaging, the driver availability, the distance. I didn't include that there. But you have different things in your process then that go into achieving overall your CTQ parameters for the pizza delivery. Now, just a short mention, critical to quality characteristics. We're going to be, we've learned about the normal distribution. We're going to be talking a lot about the normal distribution. Many physical parameters are normally distributed. For example, this is the defect picture. You're depositing these lines here. These widths normally follow a normal distribution. Thicknesses, film thicknesses, for example, lengths, weights. Other parameters are not. Waiting times are a typical example. Call centers, post office, treatment times at the doctor, leakage currents, oxide breakdowns, and type of lifetime data, or for example, events that occur very rarely. For example, when you need spare parts or you have some kind of accidents. These are described by different types of distribution functions. We have like oxide breakdown is the Weibull function, exponential, used a lot for arrival times, inter-arrival times for customers, for example. And these you can identify either because you are very familiar with these processes and you know that they follow these types of distributions, or you can look at the data, see if your histogram is skewed, see if you have some kind of natural process limit that's often zero, that doesn't ever go below zero, for example, or some kind of time dependence. And yes, we're focusing a lot on the normal distribution. Some of our statistical techniques, it won't matter. Depending on what process you have, you can still use the techniques that we go over. And for others that do require normal distribution, you can do some kind of data transformation and then transform the data into a normal distribution. We have another example here of the critical to quality characteristics from candles, just as another side of things. In this particular example, we're looking at the quality mark for candles. This is an award given by the European Candle Association, which is awarded to members if their candles fulfill all requirements, including high quality raw materials, the dimensions, the weight, the color, and if they burn perfectly. So for example, a bright calm flame, ideal wick curvature, which is actually what you see here. No sooting, this is bad. No dripping, must burn the right amount of time and have minimum wax. So here is an example of, again, the voice of the customer. Maybe the customer is not quite so stringent, but if you want this quality mark, if you want your candles to have this stamp of approval that people recognize, then you have to identify then for these VOCs, you have to identify the critical to quality parameters that go into that. You have to look at how they're distributed, how you would measure them. And in this particular example, of course, when you have a candle, if you burn it, it's not there anymore, it's destructive. But the manufacturers pledge themselves to continuously monitor their products as they come off the line. And this brings us to our next point. Maybe a very concrete example. We're an office furniture factory. We produce tables for classrooms. And we know a critical to quality parameter is the table width. And we want this to be 80 centimeters, for example. So we know they'll never be exactly 80 centimeters, but we want to make sure that they look identical to our customers. So we've got our CTQ, one of many probably, and we want to make sure that we now define the specifications for the table is our unit, we have the CTQ as the width, we have a specification so that our customers will accept our products. And we will have variability. Some may even be too wide or too short. We have to scrap them and throw them out. And we want to, of course, minimize that. And since width is normally distributed, we could estimate based on our normal distribution of our table widths, we could estimate how many of our tables fall outside of our specifications. How many would we have to throw out? So we produce lots of tables. We produce every day thousands of tables. How do we proceed here? So when we are designing, producing, and delivering products to satisfy customer needs, so here our table, we're going to take advantage of a few statistical tools. So when we have large quantities and we want to see whether our entire population, of tables for the day, the month, the week, the month, we want to see how good that is. What we generally do is to take a sample. And what we do is we verify if our sample meets the requirements for our CTQ. And then we will project the quality of the entire population based on the quality observed in the sample. And if variability exists, just checking one unit will not be enough. So then that brings us to the question, how many tables do we need to measure? How big should our sample should be? What is the relationship to what we measure in the sample and the quality of the population? If the sample contains 10% defectives, does that mean the population contains 10% defectives? And the answer there is no. How can we use our sample to estimate the amount of defectives in a population? And the science of statistics provides these answers. It provides means of describing and quantifying the variability in a population and offers methods for estimating population quantity from sample quantity in the presence of variability. So we have specific methods that we're going to see. For example, control charts, and it's not working here, control charts, sampling plans, designed experiments, and regression analysis that we're going to see. They're used throughout the DMAIC process, and we're going to be revisiting these as we move through the DMAIC cycle, using all of these to control, to measure, to improve our critical to quality characteristics.